Assalamu alaikum students. Lastly we read about the hydrogen spectrum and we read about the Lyman series. Hydrogen spectrum and we read about actually Lyman series. So there are many more series like Balmer series, Boston series, Bracket series, Fund series. Actually how we are going to make them? Let's make a diagram here. It will be easy for we people. And this will be n is equal to 1 energy level. Let this will be energy level corresponding to n is equal to 2. Let this will be energy level for which n is equal to 3. N is equal to 4. N is equal to 5. N is equal to 6. As we are approaching higher and higher, the levels get closer and closer. N is equal to 7. N is equal to 8 dash dash dash. I will put simply n is equal to infinity. Now what we read lastly, we read whenever there is de-excitation of electron from n is equal to 2 to 1 or from 3 to 1 or from 4 to 1, 5 to 1 or from 6 to 1, 7 to 1, this to 1 or from infinity to 1. We get a series. That series was Lyman series and it fall in an ultraviolet region of electromagnetic spectrum. And in this very series what we read that when the electron de-excites from n is equal to 2 to n is equal to 1, there is a small energy difference between the two. That means small frequency but large wavelength. So you have to remember, if you are asked in the Lyman series, when you will get a larger wavelength, when the electron excites from n is equal to 2 to n is equal to 1, and when you will get a shorter wavelength, when electron excites from infinite energy level to level number first. Then there is a second series which is known as Balmer series. Now what is Balmer series? For Balmer series you have to remember, when electron excites from n is equal to what? N is equal to 3 to 2, 4 to 2, 5 to 2, 6 to 2, 7 to 2, and 8 to 2. This is then infinity. Okay, this is called as Balmer series, and this Balmer series lies in visible region. So what is Balmer series? Balmer series is the series in which a line spectrum in which electron gets de-excited from higher energy orbit from n is equal to 3, 4, 5, 6, 7, 8 up to, but there is only lower energy level, that's 2. So among this, once you will take difference of this and this is very much small difference. So when the electron de-excites from, if you are asked, when you will get a larger wavelength in Balmer series, we will get once the electron de-excites from n is equal to 3 to n is equal to 2, because it will be having a small energy difference, that is a small frequency. The one's frequency will be small, for that very radiation wavelength will be very large. But for this very case, when the electron de-excites from higher n is equal to infinity to n is equal to 2, in this very case, for that very spectral line, we are having a huge energy difference. That means huge frequency, that means lambda minimum. So this corresponds to lambda minimum, and this corresponds to lambda maximum. Here this corresponds to lambda minimum, and this corresponds to lambda max, m max. The same will be for rest of the series. If we are having then another series that's called as, this is Lyman series, this is Balmer series, then we are having the Paschen series. What is Paschen series? Now simply, when the electron dioxide is from 4 to 3, it will be then 5 to 3, it will be then 6 to 3, it will be then 7 to 3, it will be then 8 to 3, and it will be then infinity to 3. We'll get another series which we called as what? This is called as Paschen series. Paschen series, and it falls in infrared region. Infrared region. So again, this will correspond to lambda m max, and this will correspond to lambda minimum in this very series. The same will be so Lyman series, Balmer series, Paschen series. Then there is another series which is called as bracket series. What is bracket series? So when the electron dioxide is from n is equal to 5 to 4, 6 to 4, 7 to 4, 8 to 4, and infinity to 4. We are having another series that is called as bracket series. Bracket, BK में short में लिखो, bracket series, BKT, bracket series, and it also falls infrared region. So this will correspond to their what? Lambda max, and this will be the lambda minimum for the series. Similarly, we are having another fund series. What will be the fund series now when the electron dioxide is n is equal to 6 to 5, from 7 to 5, from 8 to 5, and from infinity to 5? Then we will having this very series called a fund series. Fund. Lyman series, Balmer series, Lyman series, Balmer series, Paschen series, bracket series, fund series, and it also fall in infrared region. Infrared region. This will be the lambda max, and this will be the lambda minimum. These are all series. You are having the homework that you have to calculate lambda max and minimums for the respective. For Lyman series, I have yesterday calculated. Lambda max comes out to be 1216 angstrom, and lambda minimum comes out to be 911 or 912 angstrom, nearly that. This is regarding the uh, knowledge regarding the hydrogen spectrum. You have to remember it. Just in our next lecture we will be having some numericals related to this. Till then, Allah Hafiz.